Good morning, 8th grade. I hope that we're having a great start to our day, and I'm happy that we're watching this video. Our video this morning is going to be all about the distributive property. So if you ever have any questions about the distributive property, this is the place to check. If you have any other questions, just message me on Schoology or feel free to leave a comment in the comment section. But without further ado, let's get to our distributive property video.
Today, we will be talking about the distributive property. So let's get into it. The distributive property, you can see in the box for any numbers A, B, and C, when you have the quantity or A times the quantity B plus C, you ultimately end up getting AB plus AC, and it's the same thing in reverse, okay? It also works for subtraction, but there are a couple different words that we need to know in order to help us out. So first off, a term is a number, variable, or the product of a number and one or more variables. A constant is a term that has no variable. A coefficient is a term, there's a numerical factor of a term or the number in front of a term. So for example, 5x, 5 would be your coefficient. Like terms, like we talked about in a previous class, in a previous video, like terms have the same variable factors, same variables raised to the same power, and an expression is in simplified form when it contains no like terms or parentheses. So let's get some practice here with the distributive property. What value of x would make the linear equation 4x plus 3 times the quantity 4x plus 7 equal 4 times the quantity 7x plus 3 minus 3 true? What is the best first step and why? Well, in this case, the best first step would be trying to simplify things by doing the distributive property. So I'm going to rewrite it. So I have 4x plus 3 times the quantity 4x plus 7 equals 4 times the quantity 7x plus 3 minus 3. So what I need to do is I need to take my outside term and I need to distribute it. I need to multiply it by all of the terms inside the parentheses. So I do 3 times 4x and 3 times 7, as well as 4 times 7x and 4 times 3. And then everything else drops. So I have 4x plus 3 times 4x gives me 12x, and 3 times 7 is 21. 4 times 7x is 28x, and 4 times 3 is 12, minus 3. And now it's important for me to try to figure out what are my like terms. Again, like terms are numbers that have the same variable that have the same exponent. So 4x and 12x are like terms on my right-hand side. And also numbers that don't have any variables, constants, are also like terms. So 12 minus 3. So 12x and 4x when added together give me 16x plus 21 equals 28x. 12 minus 3 gives me 9, so plus 9. So now again, my goal is to try to get all of my variables to be on the same side and all of my constants to be on the other side. So I'm going to subtract by 16x on both sides. So I get 21 equals 28 minus 16 gives me 12, 12x plus 9. And now I need to subtract by 9 on both sides so I can have all of my constants on the same side. 21 minus 9 gives me 12, so I have 12 equals 12x. This is like 12 times x, and the only way I can undo that multiplication is through division. So I'm going to divide on both sides, and I find that 1 equals x. So 1 is my value of x that will make that linear equation true. Let's try another example. What value of x would make the following, that's supposed to be linear equation, true? So 20 minus the quantity 3x minus 9 minus 2 minus the quantity negative 11x plus 1. In this example, it's really important for us to know behind this minus sign in front of my parentheses, there's actually a 1. So it's almost like it's a negative 1 that's being multiplied through. And I'm going to do the same thing. So it's almost like a negative 1 times negative 11x plus 1. So I'm going to distribute that to each of these parentheses. So I have negative 1 times 3x and negative 1 times negative 9, negative 1 times negative 11x, and negative 1 times positive 1. So I get 20 minus 3x plus 9 minus 2 equals positive 11x minus 1. So now I need to go ahead and I need to combine some like terms on my left-hand side. So 20 plus 9 is 29, minus 2 is 27. So I have 27 minus 3x equals 11x minus 1. I'm going to add 1 onto both sides so I can get my constants to be on the same side. So I have 28 minus 3x equals 11x. I want to move my negative 3x over to the other side, which means I need to do the opposite of subtracting, which is adding. So I'm going to add by 3x on both sides. And I get 28 equals 14x. Again, that's 14 times x, so I need to divide in order to get rid of that 14. And I find that 2 is equal to x. So 2 is the value of x that would make the following equation true. I've got 2 more examples, so let's get into it. In this case I have a fraction, but there's really nothing that should be super concerning because I can still distribute fractions like I would distribute any other number. So I know here I need to distribute this 1/2 to 4x, and I also need to distribute the 1/2 to 6. Remember, this is like a negative 1 on my right-hand side here that needs to be distributed to the 5x and distributed to the 9. So 1/2 times 4x is the same thing as 4x divided by 2, which gives me 2x. And 1/2 times 6 is like the same thing as 6 divided by 2, which is positive 3. And that minus 2 gets dropped down. Negative 1 times 5x is negative 5x. And negative 1 times positive 9 is negative 9. So now again, I need to combine some like terms. So I have 2x plus 1 equals negative 5x plus 9. Sorry, minus 9. Now I'm going to try to get all of my variables and my constants to be on different sides. So I'm going to add by 5x on both sides. So I have 7x plus 1 equals negative 9. I'm going to subtract by 1 on both sides, and I get 7x equals 10. Sorry, negative 10. And I'm going to divide by 7 on both sides. And I find that x equals negative 10 sevenths. And I'm going to leave my answer like that. It's okay that I get a fraction as an answer. One more example. So I have 2 times the quantity x plus 1 equals 2x minus 3. So I'm going to distribute first. So I have 2 times x, which just gives me 2x, and 2 times 1, which gives me 2, equals 2x minus 3. I'm going to subtract by 2x on both sides. So I get 2 equals negative 3. Well, in that situation, that can never happen. So maybe I did something wrong. So I'm going to go back to my 2x plus 2 because I know I distributed correctly. 2x minus 3. I'm going to put my constants together, and I get 2x plus 5 equals 2x. And now I'm going to subtract by 2x on both sides, and I get 5 equals 0. Well, in that case, I can see that 2 does not equal negative 3, and 5 does not equal 0 in any lifetime. So in this case, that automatically tells me that my solution is actually no solution because there is no possible answer that will work in this situation. And that's the end of my video. So if you have any other questions or comments, please leave a comment in the comment down below, or in that section down below. If you have any other questions, feel free to message me on Schoology. But until next time, I hope that you have a great day.